All right, here we have a energy versus position graph for a box on a spring. You can see that when we change the spring constant, the shape of the graph changes, and then when we increase the amount that it's stretched, we are raising the total energy that's actually in the spring system. Changing the mass doesn't really do anything. Even if we stretch this out, the mechanical energy increases. If we change the mass, nothing happens. Now, if we let this object start to move, we see that the potential and the kinetic energies are changing into each other. Now, the points where the kinetic energy is at the lowest are the turning points. That's when it's turning around. In the middle, you have maximum velocity and no potential, and then you go to the other turning point on the left where the velocity is again 0, and it's physically turning around. So this is how the potential energy function looks for this type of a system. We can change certain things, like if we lower the spring constant, we're lowering the total energy that's stored in the spring. And you can see that the kinetic energy transfer is a little bit slower. You still have the same features. You have turning points where the velocity is 0, and the maximum velocity is in the middle where the potential energy is going to be 0. Isn't this just mesmerizing? Yes.